Hi guys, this is a 3.14 maker, and today I shall teach you guys about solving linear inequalities with no possible solution. Our equation for today is 2x greater than 10x squared plus 5. I repeat, 2x greater than 10x squared plus 5. Now, if we look at it, we can see that whatever number we substitute to x will never make the equation be true, since 2 times any number can never be greater than 10x squared plus 5. For example, let us say x is equal to 1. So, we substitute x from 2x is greater than 10x squared plus 5 with 1. And if we do that, we will form 2 times 1 is greater than 10 times 1 squared plus 5. Now, if we simplify this equation, we will form 2 is greater than 15, which is not true. Now, let us move on to another root, a much bigger one, and that is 5. So, we substitute x from 2x is greater than 10x squared plus 5 with 5. In doing so, we form the equation 2 times 5 is greater than 10 times 5 squared plus 5. By simplifying this equation, we will form 10 is greater than 255. And that is not true. In conclusion, we can say that no root can and will make the equation 2x is greater than 10x plus 5 correct, thus not having a solution, and 2x will never be greater than 10x squared plus 5. Now, for another topic, solving linear inequalities with only one possible solution. Our equation for this topic is negative x squared plus 50x minus 108 is greater than or equal to 517. I repeat, our equation for this topic is negative x squared plus 50x minus 108 is greater than or equal to 517. First off, we need to transpose 517 to the other side of the equation. In doing so, the equation is now equal to negative x squared plus 50x minus 100 minus 517 is greater than or equal to 0. Now, we shall simplify the equation by adding negative 108 to negative 517, which in turn will become negative 625. But since x squared is a negative number, we need to multiply or divide the whole equation by negative 1. So, negative x squared becomes positive x squared, positive 50x will become negative 50x, negative 625 becomes positive 625. And lastly, since we are multiplying or dividing the inequality by a negative number, we need to reverse the greater than or equal to sign to a less than or equal to. From this newly formed equation, we can factor it out, wherein the factors of the constant term is equal to the linear term when added. The two factors that when multiplied is equal to 625 and when added is equal to 50 are the factors 25 and 25. Now, since the constant term is positive while the linear term is negative, you can say that both factors are negative. Then place the gathered information into a binomial, which is x minus 25 times x minus 25. Now, we shall find what the critical points are. And since it is less than or equal to 0, we can say that x minus 25 is equal to 0. Now, by isolating x, which is by transposing negative 25 to the other side of the equation, we can say that x is equal to 25. The same goes for the other binomial. Now, to graph this in a number line. First, make a number line in any interval you would like. I'll be using a negative 50, negative 25, 0, positive 25, and a positive 50 interval. Secondly, plot the value of the critical points in the number line by placing points. I'll be only plotting 25 since it is the only critical point. Now, we shall graph it to show if the resulting number is positive or negative or 0, wherein we make 4 columns and 4 rows. First column being the binomials, the second being any number less than 25, the third one being 25, while the fourth column is any number greater than 25. The first row being the numbers equal to x, the second being the first binomial, wherein x will be substituted with a number from the rows, the third being the second binomial, where x will also be substituted, and the fourth is when the binomials are multiplied. Now, we shall substitute the x from the binomial with what it is equal to from each column. After simplifying, we shall place the result in the graph, whether it be positive, negative, or 0. Additionally, the fourth row is just the second and third row multiplied. After graphing, we shall find out which column we shall use. Now, since the equation is less than or equal to 0, the resulting number shall be less than or equal to 0 or negative or 0. And if we look at the graph, we can see that there is no column that is less than 0, but there is one equal to 0, and that is the column where x is equal to 25. So we shall use this number. The final answer should be placed in brackets, wherein it tells that x such that x is equal to 25. The final answer should also be graphed in a number line, so make a number line with the same interval as the one drawn last time and plot a solid point at 25. Solid because the equation uses the symbol less than or equal to, and that is the final answer.